Hi, hello, good morning. I'm Dr. Abdul Pasha, working as Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad, from the Department of Electrical and Electronics. So, here it is about the course we are discussing power system operation and control. So, in this course, I'm going to give presentation on optimal placement of capacitors. So we discussed so many cases of introducing capacitors which will influence the system performance as in the manner of improving the power factor case, any lag of response generated from the system. So these are the features we expected a lot, and these can be overcome by placing the suitable form of capacitors into the line. So coming to here, optimal placement of capacitors. Here the problem of optimal capacitor in a simple radial distribution system involves the determination of the locations and also sizing of the capacitors. So which are going to be installed at the buses for minimizing the power loss. So and also it involves in improving the voltage profile of the whole system. So that means usually we treat a radial distribution system in a whole entire distribution network. So for the case of radial distribution network, the optimal placement of the capacitor is very much important. So here it determines the locations and the sizing of the capacitors, and also at each bus, means at respective substation, this is for minimizing the power loss portion. This will be the main advantage to reduce the power loss portion, and also it improves the voltage profile. Voltage profile it also improves. So these are the two factors which will be ready to done by this optimal placement of the capacitors. The type of the connection may be in a series connected manner or parallel connected manner. So here we will go for searching possible locations for optimal placement of the capacitors, which are being calculated using two parameters. What are those means? Loss sensitivity factors and voltage stability constraints. We will first look into the what are the loss sensitivity factors. Onto the given line where the expectancy of loss is more. Based on that considerations, they will designate some locations and identify it, and based on that the optimal seizing of the capacitors are going to be takes place. And also the thing is that stability of the voltage index. So voltage stability index also to be considered for the optimal placement of the capacitors. How the voltage stability on the particular line or at each respective bus, what are the stability constraints? If maybe bus 1, bus 2, like that. At any cost of the bus, what is the voltage stability? What is the voltage stability? That constraint also considered here. So here a pollination algorithms are supposed to be developed as the latest advanced technologies. Here this is to determine the optimal locations. One of the best suitable algorithms, those are supposed to be introduced into the systems. This is supposed to determine the optimal location of the capacitors and also the size of the capacitors. So these are very much important to be considered. So generally here the best practice is to keep the capacitors as close as to the devices to reduce the length of the electrical case. Means when you suppose it to ready to insert the capacitors, as it is almost nearer to the device to reduce the electrical length, which helps with noise suppression. Means whenever the line is energized, around the boundaries or region of the line, the expectancy of noise is more. This may be due to corona also. Usually we treat corona as hissing noise produced on the surrounding regions of the conductors. So due to which there may be a lot more distortions in the line. So here the thing is that we will treat best practice to insert the capacitors nearer to the devices to reduce the length of the electrical line. When you are goes on increasing the length of the line, what happens? Loss coefficient will be more. When you are goes on increasing the length of the line, then loss expectancy is more. Then load side you cannot see that expected outcome cannot be reached. So due to which it makes more complex to the whole system. So that's why the thing is that keep all the capacitors as nearer to the devices to reduce the length of the electrical lines. So here the resultant is it helps with noise suppression and other beneficial things. Beneficial things means just now I suggested loss coefficients may be reduced and also it can ready to reduce the noise levels. These are the two benefits when you are going to keep these capacitors nearer to the electrical components or devices. This will reduces the noise humming and also which makes sure about increasing the efficiency of the system, reducing the noise levels and also loss coefficients also to be reduced. So to incorporate of the capacitors into the whole power distribution network which offers economical and operational benefits. Operational benefits are including increasing the loading capability. Loading capability may also increases, reducing the loss coefficients, just now we discussed, power factor improvement case. When there is a power factor with unity or leading in nature, then your load are safe side. So loads are supposed to be under secure conditions with the operating power factors ranges from leading to unity power factor cases. These are can be done by only keeping the capacitors nearer to the electrical systems. So economical aspects are also dealt. So we should expect only very little bit amount of the loss coefficients. So economical aspects it should be very economy in nature and operational benefits also supposed to be getting more. Otherwise we will see with more loss coefficients in the line. So usually we treat capacitor as a device which stores energy in the electric field manner. So this is achieved by having two oppositely charged electrical conductors. They are supposed to be separated by dielectric materials. Usually how can we treat a capacitor when there is a capacitor like this? How can you say that a capacitor is formed means any two conducting surfaces means electrodes. Any two conducting surfaces separated by an insulating media. This is insulating media. This is insulating media exhibits the property of capacitance. So the dielectric material may be paper, mica like that we can use. So large bulk in aspect they will treat based on the application. So here any two conducting surfaces, these are the two conducting surfaces, they will be treated as electrodes. So these are separated by one of the insulating media that exhibits the property of capacitance. So here in bulk applications, we will treat a bunch of capacitors in series or parallel connected manner. So that bunch of capacitors will results to give leading power factors. So coming to here, they are supposed to be separated by dielectric materials, means the medium should be exhibited according to the given application. Based on that, selection of capacitors are to be done. So usually power capacitors are constructed of several smaller capacitors. That means what we suggested just now, when a couple of capacitors are considered, commonly they refer to as elements, windings or packs. Elements, windings or packs. This combination of couple of referred capacitors are supposed to be constructed for small range of applications. So these elements are usually formed from multiple layers of aluminum foils, and they are polypropylene films wound together. They are polypropylene films and they are supposed to be wounded together. So when they are interconnected in nature, multiple elements will combine each other to act as a single capacitor unit. Means when they are supposed to be interconnected one each other, number of capacitors, they will be tied together. So they can be treated as a single capacitor unit. So all this whole combination will be treated as a one unit. This is a single unit. So elements are connected in series based on rated voltage and in parallel based on required kVAR range. So parallel based capacitors combination also treated as a single unit. This may treated as one of the single unit case. So C1, C2, C3. So that combination will be treated as one of the single unit case. So elements are connected in series based on rated voltage, means in parallel based they are supposed to produce required reactive voltage. So complete module is enclosed in a hermetically sealed tank. That means any air from the unit is removed and they will be replaced with a dielectric fluid case. This may causes the capacitors to function as in suitable manner. So here units include like bushings with the terminal capacitors that are used as one of the connection points, and they has to maintain electrical creepages and clearance requirements. So in distribution systems, these are one of the capacitors. They are ready to provide a reactive power. So this is to be to the offset, which will be inductive loading from the devices like motors, arc furnaces and lightning loads. All these type of loads are inductive in nature. So they will give leading lagging VARs. So we should provide a leading VARs to these inductive loads. So that's why the capacitors will provide reactive voltamps that should be applicable to the inductive loads in nature, like motors. So all the motors are inductive in nature, as its winding carries, that will be inductive in nature, and also arc furnaces and lighting loads. These will exhibit the one of the inductive loads. They require large amounts of these type of leading VARs, leading reactive voltage. That's why it requires capacitors in a bulk range. So incorporation of these capacitors into the power distribution system will offer economical and operational benefits. So that may include increasing system loading capability, reducing the loss coefficients, improving the power factor. If not it is possible, then this will be lagging behind that applied voltage. Whatever the loads inductive in nature, we are connecting to the system. So because of this placement of capacitors in a distribution network, which offers economical and operational benefits. Unit cost also to be maintained suitably for the load or consumers, which will increases the loading capability of the whole system and reducing the loss coefficients and also improving the power factor gap. So these are the features generated from the systems when you are keeping a couple of capacitors or making as a single unit. Small units can be together merged as a bulk unit to act as a one of the capacitor banks. So there are two primary classifications of power capacitor units. Usually we consider the classification based on the selectivity and load considerations. Here there are existence of two primary cases. Internally, the fused units consist of elements which are each protected by a series connected fuses. That means they will treat inside the capacitors which are enclosed in nature. They should be covered suitably. So as an element it fails, internal fuse will protecting that element clears. So after the fuse clearances, voltage on elements in parallel with the failed element rises and the voltage on the capacitor unit also increases. This may usually happens when there is a clearance about the fuses and voltage on the elements are connected in parallel to each other. With this failed element will raises the voltage on the capacitor banks. So unfused units do not include any fuse protection. So with the unit, it should be the one of the complex case. So that's why they has to commonly utilized all the fuses externally as a bank of systems. Means couple of capacitors which are together connected in a single system manner. This makes the system to be stable operating conditions. So like unfused units, they are available in three different product duties. That is primary performance, which may differs, which are summarized like types of capacitors with switches. That combination is treated as types of capacitors with switches. So that means a capacitor switch is used to energize and de-energize the capacitor units and banks. Capacitor switch is used to energize and de-energize the capacitor units. It makes on and off of the operation. It may be a single capacitor or number of capacitors connected in a unit section. Number of capacitors connected as a unit section also. The switch combination will be treated. So here switch could simply be used for localized maintenance. That should be purposes to take the equipment in offline for a service aspect. So for service aspect, the switches may be simply used for localized maintenance purposes. So this is to treat the equipment in offline. It can be easily serviceable. If not, we are not making the service to the equipment, then they will treat for serious disorders in the system. So this may be achieved by utilizing hot sticks. Hot sticks we are using to make the control of topologies like electronic interfaces are going to be provided for this couple of capacitor units. So switches are oftenly utilized as a safety feature. This is to remove the bank from the service when they are operated beyond intended design points. So to make this intended design points, we should treat the switches to be utilized under safety feature conditions. So they remove the bank from service when operation is beyond the intended design cases. So this may be achieved when there is a lag in the system. So when there is service expected, switches are often utilized as safety feature. So based on that, we can treat the switch combination and we can release into the service conditions of all or all the combinations of the capacitors. So here switches can also be combined with the relays case also. So they treat sensors, control packages to provide significantly more sophisticated that will engage and disengage a bank under specific application conditions. So this may like temperatures, time of DNA and system loading conditions. So they also combined with the relays means relays are one of the protective devices. They treat also like a switch. When this switch combination is connecting to the relay means then it will be supposed to act as one of the protective elements. And sensors also plays a very key role. It will immediately act to the cause opposing to the system. One of the control packages also provided significantly that gives more sophisticated results to engage and disengage a bank of capacitors that should be operating under specified applications. When the application is suitably designed under the conditions like temperature variations, under hot or cold conditions or rainy seasons, it may be treated. So the time of the day is different. It should not be similar at all the cases. So under the loading conditions also differs. So your loading cannot be same at all the time. So it may be variably changes time to time. So that's why during that conditions also this optimal placement is required. So two primary insulation methods are provided for the whole capacitor switches. They are oil and vacuum designs, oil type of capacitors and vacuum type of designs. So usually in our regular applications for fans, we will treat oil capacitors, paper capacitors, like that. So based on the application suitability, we will select the type of the capacitor. So usually users will typically differentiate between two based on their specific application needs, like expected number of operations, ambient temperature conditions, speed and rating requirements. These are one of the key features when they supposed to consider specific application needs of whole capacitors. They expect the number of operations, ambient temperature cases, and the speed requirements of whole systems they are going to be treated. So what are capacitor banks? Capacitor bank is nothing but multiple number of capacitors. If you connect together, like if you have like this one, these are the number of units. So number of units may be treated like C1, C2, C3, C4. So this combination may be treated for connecting to any one of the section. So this is supposed to be treated as one of the capacitor bank. So some couple of small capacitor ranges, they together connected in parallel connection or multiple capacitors combination will treat for capacitor bank. So a capacitor bank is an array of multiple capacitor units. They will combine in series and also in parallel connected manner. And this is to meet the overall system needs. We may also connect not only in parallel, we also connect series connected manner. Series connected combination also treated. This may also serve as one of the capacitor banks. This may also treated as one of the capacitor banks. They connected to the whole system. So here these units are commonly housed in a metallic frames. So this entire combination is situated in a metallic frame where each level is referred to as a block. Where each level is referred to as one of the block. So typically the units are connected in series. They has to meet the maximum operating voltage and in parallel to achieve the necessary reactive voltamps requirements. Means when you are supposed to treating a bunch of capacitors, they are supposed to be kept in a metallic frame, just like a box type of arrangement. So where each level is referred to as one of the block, like we can treat number of blocks of the capacitors. Typically units are connected in series. They has to meet the maximum operating voltage. When it is the requirement to operate with maximum voltage and in parallel to achieve the necessary kVAR requirements, this is usually preferred. So that is the requirement of the capacitors case. So usually banks of capacitors are available in a variety of orientations to meet the user's footprint and application needs. Banks are available. It means couple of capacitor setups are going to be considered. Those are treated as banks of capacitors. That means the variety of orientations are to meet the user's footprint and application needs. So the units may be oriented vertically, horizontally, or flatwise. So the units may be oriented vertically, horizontally, flatwise means the way in which the couple of capacitor banks are going to be connected together. So that banks may be constructed in such a manner to meet the power factor requirements mostly. So where one block means one frame houses multiple phases where each phase is isolated within its own block and arranged next to one another. That means where each phase is isolated within its own block and then stacked on the top of the each other case. This arrangement is most suitable to construct the number of capacitors at required load conditions. So during lagging and mismatching conditions of the voltage profiles, we are going to keep this couple of capacitors. So what are the different types of capacitor banks mostly we will prefer? Basically, there are 5 types of capacitors banks. One is pole mounted case. Second one is metal enclosed. Third one is mobile applicated. Fourth one is open air. Fifth one is specially designed application oriented capacitor banks. So the design of capacitors which are in pole mounted nature, and when it is supposed to be covered by metal enclosure, and third one is mobile constructed, fourth one is open air, and finally specialty application means based on the load requirement as sensor based and relay based construction. We treat a specialty application of the capacitor cases. So coming to pole mounted capacitor banks, they contains a frame that is mounted directly to the utility pole. It is connecting to the utility pole directly. These banks are most commonly contains a 3-phase design. So in which each phase has 1 to 3 units. That means 3 to 9 units per banks are going to be constructed. When the banks are commonly containing 3-phase design, each phase will has 1 to 3 units. That is based on the load requirements. And also it is constructed up to 3 to 9 units per only one bank of capacitors. These are very easy to install. They will maintain and locate for optimal performance. They can houses easily on a full range of accessories, and they can control the operations and availability in fixed and switching operations. So mobile based capacitor banks are usually designed to be transportable. They are ready to provide rapid deployment and flexibility to address the user needs without having the installation of the permanent equipment case. So mobile banks are available with a variety of trailer options like flatbeds, single drops, double drops. These are the arrangements we will suppose to provide. And they are also scalable from a single trailer to multiple trailer case. That is based on the application needs. We will consider couple of capacitors. So most commonly the type of capacitor banks utilized are emergency outage support, maintenance applications, temporary construction power, or we may ready to provide loading assistance while delaying large capital investments. So these are also one of the application treatments we will consider to relocate all these capacitor arrangements. Coming to metal enclosed capacitor banks, they will feature a metallic surrounding. So metallic surrounding are provided for housing the number of capacitors together. So this metallic enclosure will features to serve as one of the protection barrier into the system. This will enclose to protect the public and personnel against inadvertent contact to energized equipment. So in addition to the systems susceptibility to animal and pollution related outages, these banks are suitable for indoor, outdoor and underground installations cases, and also available in multiple step configurations. They are allowing for scalability to meet the system requirements easily. So usually users benefits from decreased installations labor as this package is pre-assembled in nature. They will be shipped ready to be installed easily. So mobile capacitor banks are designed to be transportable to provide a rapid deployment, and also they're flexible to address user needs without having that installing permanent equipment in the nature. So mobile banks are available with a variety of trailer options like a flatbed, single drops, double drops, like that. Multiple combinations are treated in a sequence manner. So they are scalable from single trailer to multiple trailer cases, and that is based on the application needs. So most commonly used type of banks are for emergency support outage. So maintenance applications, temporary construction, to provide loading assistance while delaying large capital investments. So these are mostly preferred in such a manner to design with the operating constraints. Coming to open air capacitor banks, they are mostly treated and provided with suitable design. These banks are typically mounted on a rigid pad, and it may contains an elevating structure. This is to provide clearance to operators and to adjust the suitable equipment. So open air capacitor banks are utilized as a range of frame structures and configurations that can also be scaled and configured. This is to meet the application needs. So as they are available in externally fused, fuseless and internally fused configurations, these banks are providing economical and reliable methods. They are for reducing loss coefficients and improving the power quality constraints. So here are some additional specialty applications for the capacitor banks to meet the customer requirements are filtering products like counteract the negative effects of the harmonics and providing more stable operating conditions. High voltage DC current transmission banks, flexible alternating current transmission systems like fax devices, HVDC systems, series compensation providing by static synchronous series compensators. Simply we may treat it as triple SC components, and the thyristor controlled switched series capacitor combination TSSC. And finally, shunt compensation methods, static synchronous compensators. We will simply say it as STATCOMs, and also SVC case. So all these combinations will typically treat as one of the filtering products that will ready to counteract the negative effects of the harmonics. They are ready to nullify the loss coefficients, and it will treat as more stable as operating systems. So this is the diagram showing how to placement of the optimal allocation of the capacitor is done for a given readable distribution network. So optimal allocation of the capacitors in the network is supposed to be done here. Here with the network, optimal placement and sizing is supposed to be selected based on the availability of the load nearer to the load centers, and which will minimize the cost of power loss, minimizes the cost of purchased capacitors, minimize the cost of capacitor installation, minimize the operational cost. All these are the beneficial features around this whole system. So because of that only we can generate more output from the whole system. By that the cost of generation will be reduced, and purchased capacitor cost also reduced. This will be using one of the method ROA. With this we can generate a suitable amount of the power capabilities. So all these are related to economic aspects, service free accepts, and all these conditions are suitable to apply for gradable distribution network cases. So likewise, this is very easy to make the optimal placement of the capacitors in the whole system by providing suitable bank of capacitors for whole the line. So these are some of the references whichever I have considered, and this will make use more extension of the capacitor banks in the various lecture notes, which gives the presentation about more information regarding the whole capacitor systems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.